Hello.
Hello.
Yesterday would have been Gord Downey's birthday.
Oh. Whew. Yeah, that was a tough year.
It was a tough year.
Yeah. Ooh.
Yeah.
Okay. A whole bunch of tough years. Okay, so there is broad distribution of feelings.
There's very little Always Sunny in Confusion in Always Sunny Philadelphia and Charlie's Face.
Yeah.
There's very little Alison Brie screaming it out in Community.
Okay.
There's quite a bit of who's that, Emma Stone crying on Saturday Night Live.
Yeah.
There's a lot of Elaine in Seinfeld. There's a lot of the SNL gif who I'm forgetting the actor with the what?
Yeah.
What?
And then there's some super ocean spray chill guy.
Yep.
Yeah. Okay.
Listen to the Fleetwood Mac and just. It's very true Chilean. That one. If you're going through hell, keep going.
Keep going.
Yeah.
Just keep going straight.
Get on your board and ride. That's the little quoted second part of that Winston Churchill quote. Throw down your longboard and out of there.
Just go straight. Don't turn around. Don't stop.
What was that? That was Churchill. On a longboard.
Super good. Hi. We hope you're okay. It's almost mid-February. Like even just sort of in normal times now is not the best of times.
What was the meme or the thing that went across Twitter the other day? Add fucking to a word to a first. It was the best of times. It was the fucking worst of times.
It was a really popular meme on Twitter.
Yeah.
So the idea was to add the F words to a famous quotation from like a classic novel. It certainly represented the times. Very funny thread, that whole thing.
Oh,
yeah, it was very good. Okay. Hi. We hope that the topic test was okay for you.
You know what though?
What?
It's done.
It's done.
So well done, you.
And the vast majority of you did it. So yay you.
Long live Gord Downey.
Yeah, long live Gord Downey. And so questions about when are the grades going to be posted, and I totally appreciate that you're wondering about that. So there are almost 1,000 of you. Our TAs have already started this morning.
They're done by supper.
No, they won't be done by supper. So just to give you an idea, the university has a policy that grades should, under reasonable times or normal times, should come back to you within 2 weeks. So that's what we're hoping for, and we're usually good at sticking on that track. If we have to ask you for an extension, then we will. We'll let you know. We'll keep you posted. And, of course, we're going to do our best to post them as soon as possible. We're not, keepers of information just to make you, upset. We won't do that. So as soon as we can, we will. It's pretty chill until the next topic test. Now, the next topic test, kind of super similar in everything as possible so that we reduce your anxiety going in, right? Because now you kind of know a little bit about how we write questions and the types of things that we're going to be evaluating and all of that stuff. So hopefully that will reduce your anxiety going into the next one and then the next one, and that's why they're all worth the same, and that's why they're just not worth a lot, because we know that they are the more challenging part of this course. Okay.
Like a worm on a string.
I love all of these drawings.
Like a
worm or snake.
Ding-a-ling.
Somebody said a swarm or something. I don't know. Okay, and then there's more drawing going on under here. There's worms. Okay, perfect. It's beautiful. Let's screenshot this and move on, shall we?
We shall.
Okay, super good. I don't like deleting it. Okay.
We'll save it.
I will. Saving it. Save. Good. And clear all drawings. There you go. Okay. You wanted to
it's another note. It's just that you're seeing all of our classes, all of these share times popping up, link by link, in the content section of course link. So as you, I'm hoping know, under course link, under content, under lectures, and then week by week, there's links that have a PDF for the slides and these asynchronous recordings on the YouTube. There is a channel on the YouTube that I add all of them to as we go. If you're looking to, I don't know, fall asleep easily or listen to us all like talking at half or twice the speed. There you go.
Okay, thank you. Okay, these are our learning outcomes for today. We're gonna, it's kind of a math day, but we'll start out slow, okay? So here we go. Ready?
Somebody got the recordings in their YouTube recommendations.
Amazing.
That's awesome.
Okay. You want to talk about these or shall I?
I do.
Yeah.
So this was actually, so I guess some of you actually in the chat told me that you got the Wordle, which was 12-letter long, and it's this. It's on the screen, so well done you, all of you. We're going to keep talking about it, right? We talked about the fact that last time, for me, previously, on Biology 1070,
Yes.
we talked about the fact that to me this is an exciting course and concept because we can study it from satellites to gene sequences. And there are many, many texts that talk about how traditionally it is studied and understood at the species level. And that's going to be where we spend most of our time. We will talk about habitats, and that's great and important, but just as a starting point, you can understand biodiversity as being this study of a difference of species in between spaces. But that begs the question, this thing called species, what is it? And maybe not surprisingly to you, nerds have written books not just on biodiversity, but on species. What do we mean? And one of the things that I may even have said in this class is that this class, this is biology in general, is harder than chemistry and harder than physics because the fundamental units that chemists and physicists use, moles and meters, are understood and don't change depending on where you were trained and when you were trained. The fundamental unit in biodiversity, some would argue, but I'll fight them, is species. And why biology is harder and why it depends is almost always involved in contextualizing and delivering answers or predictions is because we have, as our most fundamental unit, something that's inherently fuzzy. And by that I don't mean a biological mole or a fuzzy, balding, let's be charitable, balded, graying human being, or a fuzzy tamia, what's the chipmunk, or some other bit of biodiversity. I mean something that's philosophically fuzzy, something that has not Aristotelian hard edges, something that could be intermediates. That's what a species is philosophically. And because of that, we have in the scientific literature, wait for it, 36 different definitions of what a species is. And that leads sometimes to issues.
To the next slide.
Yeah. This is the one you were probably taught with the dog, the big dog and the little dog. Everybody.
They're adorable.
Yeah. So species are groups of actually or potentially interbreeding natural populations that are reproductively isolated from other such groups. Yes, you have wada. I think whenever I hear that, I hear adults in Charlie Brown. So, what does that essentially mean? It's useful because it gives us some idea of cohesion. Can they interbreed? Are the offspring that they produce viable? Or are they sterile? These kinds of things. The issue that I have with it is that we never test it. We teach each other as if this is a valuable tool because it gives you the de facto toolkit to tell you this is species A and is this other thing a member of species A or is it species B? But it's not actually used like that. Hardly ever. And then it ignores things. What about asexual species? And they're not rare. They're like all over the place. What about hybrids? They're not rare. They're all over the place. Maybe most plants. There's actually a paper out there that says, are there plant species?
It's just one plant.
Yeah. And what about connected extremes, which is kind of amazing, especially up at the poles where Dr. Jacobs works, where you can start identifying the same gull and then get on a ship and travel around the polar region. And then by the time you get to the far side of the globe, the same gull
is a different gull. Yeah.
Like what the gull?
It's like the Mobius strip of species.
Whoa. So, and this is the fact. So this is an older paper that Dick Frankham and a bunch of other men, but not all men. I see Catherine Rawls in there, and Michelle.
Ingrid.
Yeah. So
Yeah.
so not so bad. So I'll retract my criticism. Oh God, here I'm retracting my criticism.
Yeah.
But what is not useful here is the fact that this says 26. There's more, and that reflects the complexity of the question. And if you're at all interested in biological conservation, this is an important thing, because if you're interested in biodiversity, how we define species matters, and it matters. I'm going to put in my plug here that I've put in before, not because it's important to how we classify things, but that complexity of definition and concepts matters because it means we're trying to be empathetic to the diversity of life that we share the planet, or whose planet we share. Because when life is complex, one definition's not going to cut it. But we're going to stick here with species, and we're going to talk about how some units, some math as to how we measure it.
We're going to kind of pretend that we know what a species is.
Which is fine, because those definitions don't mean that we don't know it.
That's
right?
Yeah.
We have a really good handle on what species are, and come back and take graduate courses with me. I'd love to do it. That class,
totally.
what a species is. Yeah.
Great, because I'm the grad program coordinator, and
no!
I'm looking
Oh my
for and I'm looking for faculty to teach
lo
more
siento.
grad courses.
Lo
Smith,
siento, no hablo inglés, no hablo inglés.
Smith just totally volunteered.
Gotta go.
Okay, so let's bring this back to the inquiry cases and our woodlots, because we kind of like totally asked you to just like pick which of 3 woodlots you would be willing to bulldoze and put condos on. But we didn't actually give you a ton of information about these places, and that was kind of the idea, right? So just kind of reflecting a little bit on which one you sort of would pick to put condos on, or to put a parking lot on, or whatever it is.
How many other people have Joni Mitchell in their head right now? Or Counting Crows, who covered it, or lots of other people. Yeah.
Parking lot. Okay, here we go. So what we want to know now is, what more information would you like? So here's the Menti. I think the code is correct. Yes, it is. What more information would you like to know about these 3 to help make your decision? Or if you're like, nope, locked in, I know everything that I need to know, then put that in your answer as well in the Menti. But if there's something else that you'd like to know about these, that would be great. Great, you're already there. I see you answering. We'll just give you a minute or so to do that.
I have tried to put those online, but seemingly our Wi-Fi is not super well connected, because I'm sending them to nothing.
Put what online?
The Menti and the code.
Oh, okay.
There's a good double act here. Let's see, I'm even...
You're back on?
No,
You're
because
disconnected.
apparently I was disconnected. I believe I'm still here. It
Yeah,
would be pretty cool if I pixelated and went away.
Okay.
As long as it didn't pixelate into like dust that blew away. Marvelly. Because that'd give you a few years of on your own.
Okay, good. Oh, so good. These are good answers. Okay, so let's, we have 88. Let's wait until we get a bit more.
Oh, look at that. I've entered a lot of Menti things in the
Oh,
chat.
look at you. Sorry. So, and in case you're wondering, why are we doing this? the idea at the very beginning of any type of, research inquiry or anything like that is to kind of figure out what the relevant variables are, right? What do you need to know? What do you need to measure? What data do you need to collect? And so what we can do from this exercise, this is just like, what do you want to know? You might want to then figure out why, right? Why does it matter? What sort of biological levels of organization does it speak to? How will it influence your decision about the management of these places, right? So that's kind of where we're going with this, kind of getting you into just thinking about it. So even if you don't type it out on the Menti, that's not the thing here. The idea is to bring your brain into that, like, oh, wait a second, I've got to figure this out, right? So what do I value? What's important for the science and that kind of deal. Okay. Thank you.
I like some of the answers.
Yeah, these are good answers. Okay, so you want to know about species diversity, what animals, so more specific. There are good reasons for why you might focus on animals. There are other reasons for why you might not focus on animals. So that's fantastic. Which woodlot has the most resilient and fast-growing species? Whether there are any endangered, history, age, types of species. What are we looking at? This from an economic or ecological perspective.
Huge. Just a priori saying this is how we're asking the question.
Yep. What animals live there, invasive populations. Okay, environmental impact, what species live there, how dense they are, what they look like in the spring. I'm not sure I totally understand that, but that's fine.
Maybe they're thinking about species that are only visible above the surface.
Oh, yeah.
In the woodland in the spring.
Yeah, that's
things
good.
like the carpet of trout lily that you only see if you're here in April.
For like
and it's
10
literally
days,
you're walking
right?
across it for the rest of the year.
What number of species, diversity, but super good. Okay. Academic use. So even like current human use is really important, right? There are all sorts of ways
historic human uses.
So this is what I like. Somebody did put history right at the top, and it's so important to feel uncomfortable talking about these woodlots and talking about their management, because this is unceded territory. So, like, who the F are we to start making decisions about land use? And I know that, we've totally messed up in all of Guelph just by building Guelph. And yet still, some of these wild places or wilder places probably deserve us to back away a little bit in terms of how we make decisions about their use. And I think that really is important. So the history, but also the present ownership or legal or rightful ownership is important to consider in all of this. Other things, number of visitors. People sometimes use these places not only to walk their dogs, but to support their mental health. And all of the literature that shows that being in nature, even for 5 minutes a day, can make or break a mind, right? It can really help connect in some way with something a little bit bigger than yourself.
Yeah, and the fact that for many people that association is not just nature being on a path in a field, but it's being in a forest.
Yeah, how big each plot is. Yeah, like sort of acreage or the size matters because the interior is better protected when there's more around it, right? All of that edge effect stuff does actually make a difference. How likely is the area to thrive in the future? Yeah, sure. Timelines are important. These are all, so like the answer is yes to like everything, okay? And really like, you've captured the complexity of it, and I think that that's really critical.
Now, one common element to that, to a lot of your answers though, involve space, size, distance, time, how, when, future, and species. So asking questions and being able to compare species across space and time is where some of the math of the rest of our time together, where it will get to and where it will go to.
It will go to, right? Okay, good. So let's focus on number of species because that's like a, biology, quantitative formulas, math type of a thing that we can teach you about.
So it's not because it's the best, or the end, because it's a good doorway. It's like an entrance. It's like, okay, so if we're going to do that, here's a good place to start.
That's right.
Not necessarily where we stop.
No, but we can actually teach you some stuff about it. Okay. So when we think about number of species, we can think about number of species relative to the habitat in two ways. We can think about it as number of species or, sort of things that we can count about species within the habitat, or things that we can talk about species across habitats or between habitats, right? Like comparing one and another or that kind of deal, right? There's like different mathematical formulas that we can do to quantify these things either within the habitat or across. And so what we'll do is we'll go probably, well, definitely way too quickly to actually teach you. But what it will be is a kind of recording that you can use as a reference to then do the homework, which will hopefully get you practicing and using those numbers and all of that.
And I would suggest if even the fact that we have some Greek notation here is just making you kind of clench up and tense. You know these things already. You might not know these terms intuitively. You understand these things already.
Yep.
You've got this.
Yeah, exactly. So, So by the end of this, you will not feel super comfortable using all these formulas.
That's fine.
But it's about practicing using them. So hopefully you'll be able to see how we use them, and then it'll become familiar when you do the homework. Okay. So let's talk about within a habitat, keeping it nice and simple. Alpha diversity, it's an index of species richness. So number of species, it's an index of biodiversity, same thing, right? In terms of our course definition of biodiversity, number of species, all of these things are sort of synonymous, right? So alpha species diversity is one way, one index that we can use to quantify species richness, okay? So all it is number of species. So take a look at Habitat 1 and Habitat 2 and tell me, how many species do you see in each of these habitats? You can write on the slide too if you want, or pop it in the
slide
chat.
Or pop it in the chat.
Yeah. How many species in Habitat 1 and Habitat 2? Abina, thank you for going first. Good. There we go. Excellent.
Three. Lots in the chat too. Yep.
Good. Done.
3 each.
That is alpha diversity.
That's
okay? That's it. Okay?
Except when it isn't.
Except for when it isn't, but we'll talk about that soon. But that's it. Okay? So alpha species diversity is simply the total number of species in a habitat. Okay? Good. So we're gonna, that's simple, right? We just add them up. So within a habitat describes species richness of a habitat. Okay? Good. And let's take a look at when it gets a little bit complex, right? So imagine that we have here the total number of plots sampled. So you go into the dairy bush or here the arboretum and you want to figure out how many plant species or how many species there are, right? So you could count every single, no, you couldn't, because logistics and time, you'll have 3 generations of people in the time that it takes to count them all. So what you do is you come up with plots and you say, I'm going to count some over here, and then I'm going to go over here and I'm going to count some, and then I'm going to go over there. And you do multiple plots that you're sampling. And what you end up with, in the first plot, you end up with, say, 20 species that you found. And then the next one, you find a few more than what you found originally. And you keep on building until you're not finding any new species. And then you can probably say, cool, I've sampled enough to be able to say that the species richness is around 110 species, right? When it reaches that plateau or that saturation. Super. We've done this many, many times in history, right? And it works okay at a local scale, especially if you're focusing on large, easily identifiable species, right? It gets a little complex when you get into the micro world of Dr. Smith, because you'll never stop finding new species, right? The other problem comes when you're looking at a huge region like Southern Ontario, and just the flora, so just the plants, right? It turns out that you never really reach that saturation point. You never reach that plateau within your lifetime, because as you scale up, of course, you're going to be introducing a whole bunch of new diversity that you'll never really be able to fully account for. So you have to be careful when you do these counts about the actual size of the region and then the applicability of your conclusions based on the fact that you probably only stuck to a smaller size.
So in ecology, ecologists would call these kinds of curves an accumulation curve. How much diversity is accumulated over your sampling by space, in this case, plots or area, or time. How many times you go back to a place and look at stuff.
Okay, so how do we know when to stop counting?
When you run out of money.
Or when counting doesn't give you any new species.
That's a better answer.
Yeah.
But they're both true.
But they're both true, right? Okay. So here's a question just to throw at you. And again, like, don't worry about getting the answer right or wrong. It is thinking it through that's important. And if my poll menu will open, I think we're having some trouble.
We're fighting with the internet.
We're fighting with the internet.
Maybe you can see that. Maybe we're...
Are we?
I don't know.
I hope not.
So do I, but maybe we are.
Okay.
Put it in the chat if we're off.
Yeah, so you start working on it here. I'll see if I can get my poll to send out the answer. Please don't stamp yet on the slide, but we may have to resort to that if I can't get the polls to work.
I see that.
Close this. Voila.
I might have an idea.
Can you get the poll to work?
No, but...
Yeah, that's okay. Yeah. Okay.
Chat is currently offline.
Yeah, the poll is... Oh, wait, look.
What?
Woohoo!
Is it running? Oh, good. There it is.
There we go.
We lost it. You know where we lost it?
Don't tell them.
On the monitor, just to my right.
There's a lot of screens right in front of us.
We're like opening drawers. Where is it popped up? Paul!
Okay.
Holy!
Hello! Okay.
Sometimes you're the windshield, sometimes you're the bug. It's true.
Not working.
That's philosophically true. Google Translate liked it too. Thinking about it.
Yeah. Yeah. Great. Okay, a few more seconds. I know, but
Two at the same time.
I tried to sign out of Teams.
You could have a Whopper and a Big Mac. Like what?
Great. Okay. So almost 85% of you, I think, for the Monday after the topic test. That
well done.
Is very, very good.
Do some stretching. Lift up your hands. Self 5.
Okay. Wonderful. So So the answer is D. Sampling intensity is almost saturated, so almost plateaued. Not getting any more. At OG for sure, right? And then the second one that was most popular was the first one. Diversity is highest in AY, in habitat AY. And we don't know that yet. Which one may be higher once we know what the diversity is? Which one of these lines is making that statement, diversity is highest in AY, an untrue? Let me just get you back your annotation. Stamp for me the line that is, stamp for me the line that is messing with that statement. Diversity is highest in AY. Super.
Good. Nice.
Well done.
Another
Yes.
self 5.
Yeah, good. Okay. So we don't know what diversity is in AY. We know that currently with the number of plots that more have been found, but that doesn't necessarily speak to the actual diversity of it. So good. Super. Well done. Okay. Hopefully our slowdown here is going to allow us to. There we go. Species richness. Is it the only important factor? We have 2 habitats. They each have 3 species, so they are the same.
3 equals 3. I am almost certain I remember that from math.
Does that feel like biological enough?
Wrong.
It feels wrong,
Yeah.
right? Because these...
But I've quantified it, so it must be right.
No, because
No.
these two habitats, yes, they do have 3 species, but there are still the potential for differences among these habitats, right? Not only in terms of which species, because that kind of matters, but also in terms of the proportion of each species, right? Just because you have one maple tree doesn't mean that you have maple trees represented perfectly within your habitat, right?
Which one to use a maple tree?
Well, so just imagine.
Okay, all right.
Okay, so
Back off. Smith, backing off.
did you just actually mean?
I did not. I was very curious. I curious you.
Okay, so there's a difference between a forest that has one and a forest that has a whole bunch of that one, right?
You can't see the forest but for the trees.
Right. Okay, so there are other important differences like relative abundance in an area. So relative means, sort of with respect to the other species, right? So it kind of takes into consideration all of the different species and their relative contribution to the total number of individuals within that habitat.
So now I think when we say it like that, you can start to see 3 equals 3, except it doesn't really equal 3 in how they're distributed.
That's right.
So the Shannon Diversity Index. That's like a nice Irish. The Shannon Diversity Index, right?
Yeah, but
or is it?
Is it? But so okay, the big concept that we're trying to kind of describe here is called species evenness. And one way of expressing, and probably not the best way, and we'll show you why.
It's pretty good.
Is it?
Yeah.
You like it? I don't like it for like so many reasons.
Oh, but wait, I think you can guess what I'm gonna.
Okay,
I think I know why.
we're gonna remember. Okay, yeah. Okay, but one of them is because it looks, so we have high evenness. I think we can appreciate generally, right? This is high evenness because there's 2 of each, and so each one is then evenly represented.
Like if
right?
you have toddlers, forest on the left is good because you can split them up evenly amongst all of the children.
Okay, but if you have the one on the right,
Fights.
Those are low evenness because like here's like our one, not maple, but
I think
palm
that's,
tree.
Is it no, it's the...
Is that Krusty the Clown?
No, who wanted to kill Bart all the time?
I thought that was
Voiced by
no?
Kelsey Grammer.
Okay. I thought his name was Krusty, but maybe not.
No, it's Krusty's here.
Oh,
this is
okay. Sideshow Bob. You're right.
Sideshow Bob. That's
totally.
the Sideshow Bob tree.
Okay. That was a valuable 30 seconds. Okay, Sideshow Bob is by himself here, and then there's a whole bunch of these pine trees, right? So 3 species, but low evenness, okay? The Shannon Diversity Index is one of the ways that we calculate this.
It's not Irish.
And it's not Irish. This is what it looks like, and this is the guy, right? Claude Shannon. Yeah.
That's the Imperial March.
is like the Death Star leader of math in biology. Not cool. Like, this is not cool, but it actually is kind of cool because we all know what this sign means, right? And it's just an intimidating way of saying, add some stuff. Okay?
Like all of it.
Like all of it. Just clump it all together. Right? Okay.
I to infinity.
So some of we can handle, and actually this is not terrible. So let's break it down, and we'll show you how to calculate the Shannon Diversity Index. But I promise you, when I first saw this one, this was my face.
Go back and
appreciate your joke. Did you just like bomb me? Like slide? Oh, you're right. Okay, sorry.
That's who we think Claude Shannon looks like.
Okay.
It's Grand Moff Tarkin.
And this is my face, and here's how we break it down. Now, again, don't be making this face. It all totally makes sense when you talk it through, right? So don't panic. The Shannon Diversity Index
Thank you, everyone.
is equal to the number of individuals of species 1, whichever one you're starting with, divided by the number of individuals of all the species, okay, times the lawn, and who cares why, of the same number of individuals in species 1 divided by number of individuals in all the species. So you just basically calculate that proportion. This is the relative proportion of species 1 to the, of the total. And you multiply it by that same number, but you take the ln of it. And then there are other Shannon diversity indices where you take the log.
And that's why it doesn't matter.
It doesn't matter. Don't even worry about why, okay?
Or if you like it, take the bioinformatics masters.
Right.
Because then you can, there's subtle differences that are better for some cases than other. Those cases don't really matter right now.
Not right now. Okay. And then you just keep on doing this. So this is where the sum of comes to for every species that you know about in that habitat. Okay, so if you have 100 species, you got to do this calculation 100 times. If you have 5, you only have to do it 5 times. And then you take the negative. Why? Because actually this number gives you a -1, and if you take it the negative of the negative, you get a positive, which makes it easier for our brains to handle.
It's easy on the brain.
It's easy on the brain.
And you won't be grumpy like Claude Shannon.
Whew.
And try and blow up Alderaan.
Yeah. Fun fact about Claude Shannon, this equation was not designed for describing ecological trends. It was designed for code breaking in order to find patterns of different letters and number combinations within a long code during war times. And it turns out that you can also use it to describe habitats. Who would have thought? Not him. He didn't even think that.
Not him. Let me tell you. He might have.
No.
You don't know this.
No.
He took one grumpy picture.
Okay.
This is like you presuming that Ben Affleck is always sad because once he was sad when photographed. Claude might have been a jokester. He might have been like the guy at the tickling his nephews and nieces.
Not a happy man. Okay. So just to review, for the within habitat, you can talk about species richness or species evenness, right? You can also talk about them kind of together, right? So when you're talking about species richness, the index that we've introduced to you is the alpha index. And when we're talking about species evenness, the index that we've introduced to you is the Shannon diversity index. There are about 30 or 40 different indices. We're only going to teach you 4. So those 2 are done. We're like halfway through.
And some of the questions in the chat, just don't start. Remember, so far we are all still talking about alpha diversity. So looking at a place.
Yeah.
Not across
One
space
place.
and not across time. So evenness is different than richness. It's more because it involves abundance, but it's still just in one spot.
That's right. Cool.
But hardly ever can you be employed describing the richness of just one place.
That's right.
They'd be like, 11, super, here's $1,000.
That's it. So when we're going to talk about across habitats or between habitats, across just means all of them together, between means we're doing some kind of comparison, right? When basically habitat 2 becomes important, we can talk first about gamma species diversity, which is basically a larger scale alpha species diversity. And what you're doing there is you're kind of merging these 2 habitats as though they were one and counting the total number of species. Okay, so it isn't total species in habitat 1 plus total species in habitat 2. No, it's total species of combined habitat 1 and 2. And that matters, right? Because we have 3 species in habitat 1, we have 3 species in habitat 2. The gamma species diversity is not 6. What is it?
See it right there.
Yes. They can calculate it themselves.
It's 5.
It's 5. There we go. Eric, good. Thank you. It is 5, right? There we go. Thank you, Eva.
Trick question.
Trick question. Well,
no.
Okay, good. So, yes, it is 5. It is not 6. And this matters, again, for making decisions and all of those things. So gamma diversity is basically just this combined alpha diversity. Good. Now.
Think of the region like that, in the gamma calculation or the definition as like the context.
Yeah.
For your contract to pay you $11,000 to describe whatever the diversity of these woodlots, but it's the context.
Yep. Okay, so we're basically creating this larger scale single habitat. Okay, good. Next, beta diversity. And you're just like itching to talk about it.
I'm not gonna though.
You're not gonna? Oh.
It'll be awfully awkward.
It'll be long. So why don't I do it?
No.
Okay, So beta diversity.
Oh, we could do it at the same time.
No. Beta diversity is a way of comparing or describing the uniqueness of either a habitat or the change over time of a habitat. So what has changed by focusing on the things that are not different or that have not changed. Is that okay?
Yep, and can I add to it?
Yes.
Can I yes and? Because
Yeah.
yes, I'm agreeing yes. But it can be the uniqueness or it could be the distinctness. So what amount, and that's just you describing things differently, right? So what amount of overlap, what similarity, or what dissimilarity?
Yeah.
Because the index can be either of those things.
Okay. So what it is, again, it's not like the Shannon diversity. That one is by far the shittiest of all the formulas. This is not as nearly as
bad. Some of these people are in calculus. They know there are far shittier formulas.
Okay, so here we go. So beta diversity is a measure of how different diversity is between habitat 1 and 2. But remember, it can also be habitat 1 at time 1 and habitat 1 at time 2, right? So over time. And that plays into the EPP and the project that you're going to be doing and all of that stuff is looking at the same place over time. You can do that with beta diversity index as well.
And also into the third unit when we're talking about physiology, we'll be looking in the Arctic through time with climate change. So there's all of these things are connected.
So connected. So beta diversity is equal to the alpha diversity in habitat 1 minus the number of species that the two habitats have in common, plus the alpha diversity of habitat 2 minus that same number of species that the two have in common. So if that is how we calculate beta diversity, why don't you try for me to tell me what beta diversity is for these two habitats. And again, feel free to write on anywhere you want. It's fine.
If you write it on your desk, we won't see it.
We won't see it, but that doesn't matter. Do that. Nice. Rebecca's got a 4 going. Wesley's figuring it out, showing their work. Yeah, good job, Wesley. Thank you. That's great. Okay, and then we've got some folks writing underneath. Emily is going with 4. Pushpinder, thank you. Wonderful. Well done. I like it. Good. Yes, 4. Excellent. Okay, we're just gonna, because like Wesley's just filling the margins there, we're gonna wait. Because you're calculating like all the things. I like it. If you're wondering how to use the formulas, just watch what's going on over here. So 3, beta diversity is 3 minus the common species plus 3 minus the common species. Yeah, is great. Right. So there's how many common species? Oh, there's 1 common species, right? So it's 2 plus 2 is 4. Perfect. Great. Okay. Well done. Nice and easy. So just to review, across habitats, species richness, and we're introducing gamma species diversity as a means of like quantifying species richness across habitats. Species richness difference, we're using beta. And again, there are multiple ways of calculating beta, so we're just going to use the formula that we introduced to you as for the purposes of this course, how we calculate beta. But you know, appreciate that there are 30 or 40 indices for all of these things, and people are arguing about which one is better and all of that stuff. It's delightful. Okay. What we want you to really focus on is how these are calculated, not in terms of memorizing it. You will never need to memorize a formula, I promise you. The thing, though, that's important to us for you to appreciate and be able to do, and not just with these formulas, but just generally to be able to look at a formula or an index and understand how the numbers move, what moves them. Right? So if I increase this variable, this will happen to my outcome or to the answer. If I decrease this or if I change this, this will happen. and basically to understand how these formulas move. When you can do that, then it kind of just makes understanding formulas, working with formulas, a lot less uncomfortable. And so that's kind of what we want to go with you on that. So to do that, we have some homework and the wrong date on the top of this slide. So don't worry about the date. Just do this when you can. And this one's kind of like, you know, an important piece of homework. And we really want you to dive in and again, not focus on the answers that you get, but the process. So we recommend that you calculate these indices for the 3 woodlots, and we're gonna in this bundle of slides, as well as in the previous bundle of slides, you'll have the iconified woodlots that we've made for you. You can use those. Again, though, if you want to use something totally different, we don't care, like whatever you want. But if you want to use those, they will be linked to a homework question, right? That you can then see if, you know, you got the right answer. More important is to go through the process.
Yeah, and to go through the process just like you experienced with the first topic test.
Yeah.
By making your own woodlots or ponds or islands or whatever and filling them with species of diggery whatever. That's you studying for the next topic test.
Totally
because
fine.
You're making up questions that you could then give to your friends, and your friends will be like, thanks, I asked for cookies.
But now I have questions. Okay, so so calculate all of the indices for each of the woodlots, and then mess around with it a little bit. So then double the number of individuals and recalculate, see which ones change, see which ones don't. Then double the number of species, or reduce the number of species, or change the evenness of the species, and really manipulate the numbers in order to figure out how they move, okay? Because the Shannon Diversity Index, I hate it, and I want you to know why. And we will tell you why later, but I want you to experience why I hate it, because it moves quite rapidly with something that has nothing to do with evenness. So go ahead and play around with it, because I think it's quite cool. And we're more than happy to discuss it, of course. Like, you know, we can talk to you about it, but I want you to kind of play around with it in your head first. So bring your calculations to next class, although it's Monday. Like, you're not going to have time to do this between Monday. Let's say for next Monday, because it was a snow day, we're off. So like next Monday, we'll give you the whole week to do it. If you would like to not calculate the Shannon Diversity Index a couple of times by hand, and then use use a scientific calculator. If you don't have a scientific calculator, all you have to do is go into Google and write scientific calculator, and one will drop down. You'll get one right there on
from
Google.
The ceiling.
Like from there. No, it'll just drop down right below where you wrote it. The other thing you can do with your phone, if you have one of these
fruit-based devices.
Yeah, I think all you need to do is turn it this way, and then it gives you a scientific calculator. See?
Now, if you turn it again, what happens?
It goes that way for left-handed people.
Good. Thank you. That's very nice of you. I've appreciated that.
Okay, so you can also go to, though, once you've done it a few times and you get the rhythm of how to do the math, you can also go to this link, and there's an online calculator that you can fill out, and then you don't have to recalculate it for when you double the number of species or number of individuals, or you're really playing around. You can use this online calculator to give you all of the numbers for the different.
And that's important to know that that's not. We would never. No one should ever be like calculation shamed into thinking that that's cheating. Doing it by hand is a really useful way to kind of understand the math once, but doing it by hand is not something, for instance, that I would ever do. I have a computer code that I've written that does it, and I revisit that code whenever I want to ask that question again. And that's right. Exactly what a link like that does.
Yeah, so when I was doing my master's, I had quite a lot of math, quite a lot of statistics, and I made myself do it by hand the first time. So that I could understand when I then put it into the computer and got a number and it looked weird, I could sort of figure out what was going on and why, because I knew what the formulas were doing and how they moved. And I think that's like one of the ways of busting open this kind of, you know, like the whole I'm not a math person. We are totally math people.
Everybody's math.
Everyone's
Yeah.
a math person. So this is how you kind of become more comfortable being a math person.
Everyone's a math person. Some of us have been unlucky enough to be associated with jackasses who don't encourage it.
Mm-hmm. Yeah.
So if you've had jackasses in your past, I'm sorry.
Where we're anti-jackass.
Yeah.
Okay, so here, if you want to use these, go ahead, and there will be the homework question on Monday will be specifically for those of you who do this. But again, we're not grading them. So if you want to work with something else, like if you have a whole bunch of aquaria at home with all of these different fish, totally calculate the indices with those. But if you want to use these, you can go ahead and do that. Okay. And that is it, because it is 3:20. So thank you. Take care.
Be kind. Be kind to yourself. Be kind to others.
We will see you next time.
And we will see you on Wednesday.
Or if you stick around, we will see you in
in
about
several seconds.
1 minute.
Wave at the camera. You almost missed my grandma's turkey joke.
Oh, I did.
It's so good.
It is.